Hello, Algebra 1 students, and welcome to the beginning of Topic 9, where we're going to solve quadratic equations, right? So we did quadratic functions last chapter or topic, so now we're going to get into solving these equations here. And our first method we're going to talk about is solving quadratic equations by factoring, right? If you remember from Topic 7, we did factoring, and again, if you remember that factoring involves that big X, where you put your C on top, your B on bottom, and you're trying to find your P and Q, these two numbers that multiply to C and add or combine to B, right? And that's the name of the game. And we're just going to take it a step further today in solving these equations. Okay, so let's get right to it. Okay, so, let me clear this. All right, so example 1, or example 2 actually, says solve by factoring. How can you use factoring to solve x squared plus 9x equals negative 2? Okay, so this is a quadratic equation. I know that because it has the x squared, right? That makes it quadratic. So we're going to use what's called the zero product property to solve this. And the zero product property says the following. It says for all real numbers a and b, if I were to multiply them, so this a, b means a times b. If I'm going to multiply a times b and get an answer of 0, then either a must equal 0 or b must equal 0. And that just makes sense to you, right? Because if I take a times 0, I get 0. Or if I take 0 times b, I get 0, right? So what we're going to do is we're going to take this equation and we're going to factor it. That'll then give us our two parentheses, which we then are going to set equal to 0 to solve for x. So that's a lot to talk about right now, so we'll get right into it here. So I'm going to bring this equation down. So x squared plus 9x equals negative 20. Now, I'm going to change colors real fast. I want to emphasize this idea of equaling 0, right? Notice that this does not say equals 0. Your first step is to make this say equals 0. And the way that we do that is we put it in this form, x squared plus bx plus c equals 0. We need to bring everything on one side to get this equals 0. So I have this minus 20 on the right, so I'm going to add 20 to both sides. Now, notice that this 20 is just a constant, where the other two terms have x's, have variables. So we're just going to rewrite all three terms, x squared plus 9x plus 20 equals, and my right side cancels, and there's my 0. Okay, so now I have my a, b, and c value. There's nothing in front of x squared, so your a is 1. We don't really care about the a right now. But my b is equal to 9, and my c is equal to 20. So now I'm going to create that big X. When you do that, I'm going to put my c on top. My c is a positive 20. Now, when that c is positive, it means your signs are the same. So either you're going to have a plus plus, or a minus minus as your two signs. So then I put my b on the bottom. This is a positive 9. Because the b is now positive, we choose plus plus. So my two signs will be positive and positive. Because the signs are the same, when we find our two numbers, we're going to add to get this 9. So I'm looking for the factors of 20 that will add to 9. So again, I just like to start with 1. So 1 times 20 is 20, but we're going to add those together, and you get 21. That's not 9. 2 times 10 equals 20, but we're going to add them together. That's 12. That's not 9. 3 does not evenly go into 20. 4 times 5 equals 20. We're going to add them together, and there's 9. And there are my magic numbers. There's my P and Q, as we'll talk about in a minute. So 4 and 5. So now my equation is going to say, and I'm going to write over here, I'll do it in purple. So now my equation says x plus 4 times x plus 5 equals 0. And here are my proverbial a and b, right, from up here, right? The times goes right there. So for these two parentheses to multiply and get 0, one of two things must be true. Either the x plus 4 must equal 0, or the x plus 5 must equal 0. One of those two things must be true. So notice, we just take each parenthesis and set it equal to 0. And now we're going to solve each one for x. I'm going to subtract 4 on both sides here. X equals -4. There's one of my solutions. I'm going to subtract 5 here. X equals -5. There's my second solution. Typically, you're going to get two solutions, and that's because it is a quadratic, x squared, two solutions. So this is how we're going to use factoring to solve these quadratic equations. Hopefully, this is just a trip down memory lane for you from topic 7. Okay. Next, okay, so next example, it says, how can you use factoring to graph the function? So we're going to take this function and we're going to graph it. Now, when you find the solutions to a quadratic equation, the solutions represent on a graph, so equal the x-intercepts. This is a big deal. The solutions equal the x-intercepts. We also call them the zeros of the function because an x-intercept has coordinates of x, comma, 0. It's called a zero of the function because it makes y equal to 0. Okay, so again, that's the as you get further in math, they're called zeros. But for us, we'll probably call them just x-intercepts. So the first thing we're going to do here is we're going to take this equation that is in standard form and set it equal to 0. So x squared minus 2x minus 8 equals 0. And we're going to factor this, right? So we have my b and my c. So here is my big X. I'll put my -8 on top. Now, the signs are different. I'm sorry, the sign's a negative, which means that your two signs will be different. So I just put plus and minus. My b is negative, so I'll put it down here. I'm going to circle this negative sign. Again, remember, we need to combine these two numbers to get a -2, which means that our bigger number should be negative. And because our signs are different, when we combine them to get this -2, we're going to have to subtract to two numbers. So I'm looking for two numbers that multiply to 8 and subtract to 2. So 1 and 8 multiply to 8. When you subtract 8 and 1, you get 7. That's not right. 2 and 4 multiply to 8. When you subtract 2 and 4, you do get 2. So these will be my numbers, so 2 and 4. But I need it to be a -2, which means the 4 needs to be negative and the 2 must be positive. That's how I overall get a -2. So the 2 must be positive and the 4 is negative. So my parentheses will be x plus 2 and x minus 4. They equal 0. And again, to multiply those two and get 0, either x plus 2 must equal 0 or x minus 4. Sorry, x minus 4. Let me erase that. X minus 4 must equal 0. So I'll solve each. I'll subtract 2 on both sides. Let me move this out of the way. So we get x equals -2. There's one of my solutions, or x-intercepts. Add 4, x equals 4. There's the other one. So now what I'm going to do is I'm going to put dots on these two x-intercepts at -2, 1, 2, and 4, 1, 2, 3, 4. Now, these x-intercepts are going to be symmetric about the axis of symmetry. So I now want to draw my axis of symmetry going right down through the middle. Well, these 2 points are a distance of 1, 2, 3, 4, 5, 6 apart. If I take 6 and divide it by 2, I get 3. I'm going to count 3, 1, 2, 3, and put a little dash there. My axis of symmetry is going to go right here. This goes to an x value of 1. That means your axis of symmetry has an equation x equals 1, which means that for my vertex, I now know that the x is going to be a 1 because this is x equals h from our topic 8 days. Again, love how it all connects. So now, to find the y of my vertex, I need to plug 1 into my equation. I'm going to put parentheses around these x's. Maybe let me change to blue. I'm going to put parentheses around these x's and replace them both with 1s. So parenthesis 1 squared minus 2 times parenthesis 1 minus 8. And you just use a calculator. I'll do it in our heads right now or with you. So it's 1, that's a negative 2 and negative 8. So that's going to be a negative 9. So there is my vertex, 1, negative 9. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll do my best. It's going to be bad. I'm just telling you right now. I'll do my best to draw a parabola going there. And the left side is symmetric. Try not to make it too V like I am. Make it more like a U. And there we go. And there's the graph. And that's how you use factoring to find the graph. You find the x-intercepts. You find the middle of them, and that's where the axis symmetry, again, that came from here. So if you want to put it up here, so the distance between my x-intercepts was 6. I divided it by 2 to get 3. That's how far each intercept should be from the axis symmetry. So a distance of 3 here and a 3 here, that's the distance. And then once you find your axis symmetry, that is the x of the vertex. You plug that x into the function to get the y value, and you're done. Perfect. That's a kind of a difficult question. Okay, last but not least here, right? Okay, so this example says, how can you write the factored form of the quadratic related to a graph? So if we did vertex form, we did standard form. Now let's talk about factored form. Here is what factored form looks like. Factored form. Factored form is y, or f of x, whatever, equals a. So we still have that a value. We haven't really talked much about a, but there still could be an a value. X minus p, parenthesis x minus q. The p and the q are your x-intercepts. So the p and the q are your x-intercepts. Again, x and y is just some other random point on the graph, and then a is that a value that controls direction and shape. Okay. So in this problem here, I have my two x-intercepts, negative 5 and positive 1. That's my p and that's my q. I need to use another point as my x and y. Now, you have two options in this case. You can use the dot they give you, which is the vertex. This vertex is at negative 2, negative 9. Now, I know that that is typically h and k, but for this exercise, we can use that as x and y. You could also use the y-intercept if that is a point that you can recognize, and that point is at 0, negative 5. Now, that is not always guaranteed, but you could use that. I'm not going to in this case. It's probably easier, but I'm not going to because I think the vertex is always guaranteed to be there. So in this case, x is negative 2 and y is negative 9. So let's plug in our numbers. So y is negative 9 equals a. X is negative 2 minus p, and p is a negative 5. Look what I do there, minus negative 5. And then parentheses, this x and that x are the exact same number. So I put negative 2 in for the first x, so negative 2 minus, and the q is going to be the other intercept, which is 1. Okay, so what you're going to do is you're going to simplify each parenthesis. So we have negative 9 equals a. This parenthesis becomes plus. Negative 2 plus 5 is 3. This is negative 2 minus 1, which is negative 3. Now we're going to multiply those, and that'll become the coefficient of a. So negative 9 equals, so 3 times negative 3 is also negative 9a. And then we'll divide both sides by this negative 9 to get a equals 1. So our a value is a 1. Okay, so now when you write down this formula, you need to replace a, p, and q with what they are. So the factor form answer is y equals, you can put 1 there if you want to or not write it, x. Now the minus p became a plus 5, so x plus 5, and then the minus q stayed minus 1, x minus 1. And there is your factored form. Perfect, great. Hope this video was okay. We'll do some more in class, and then you'll have your practice. So we'll see you in class.